Example 18. A particle moves in a straight line so that after t seconds, it is s meters from a fixed point on the line where s is equal to t to the power 4 plus 3t squared. Find A, acceleration when t is equal to 1, 2, and 3, and then the average acceleration between t is equal to 1 and t is equal to 3. So we are given s is equal to t to the power 4 plus 3t squared. V will be gotten by differentiating s, and that is the s dt is equal to 4t cubed plus 6t. And the acceleration will then be gotten by differentiating v, and that is dv dt is equal to 12t squared plus 6. So A, at t is equal to 1, the acceleration will be 12 into 1 plus 6, and that is 18 meters per second squared. Similarly, at t is equal to 2, the acceleration will be 12 into 2 squared plus 6, and A will be 54 meters per second squared. And at t is equal to 3, acceleration will be 12 into 3 squared plus 6, giving us 114 meters per second squared. So B will require the average acceleration, which can be given by average velocity over time or change in velocity over time. So we obtained V as the s dt, which was equal to 4t squared plus 6t. So at the first time, which was t is equal to 1, the velocity will be 4 into 1 plus 6 into 1, and that will give us 10 meters per second. At the second time, and that was t is equal to 3 seconds, v will be 4 into 3 cubed plus 6 into 3, and that will be 126 meters per second. So we've said that our average acceleration will be the change in velocity, which is 126 minus 10 over the time, and that is 2 seconds. Between t1 and t3 there are 2 seconds. So that will give us 58 meters per second squared.